Let us start the today's study. Today we want to study about the new chapter called thermodynamics. It is the only physical theory of universe content concerning which I am convinced that within the framework of applicability of this basic concept, it will never be overthrown. This is the statement given by Albert Einstein. Here, Albert Einstein tries to tell us that everything in this universe has got its own applicability. Whatever it is present in the universe has got its own rules, its own laws. Everything goes in this universe has got its own applicability. It is needed. And everything that is in this universe available has got some theory, some idea, some rules, some knowledge around it. This is what it is written in the beginning of your textbook to let you know that the world in which we live is much more interesting. It's much more with many laws and many knowledge, and it is full of knowledge that we need to acquire, we need to gather, and we have to be more aware regarding this. So, with a great statement from our great scientist Albert Einstein, let us try to study, let us start our journey of study into the chapter called thermodynamics. My dear students, let us first understand the physical meaning of this word thermodynamics. Here, thermodynamics is the word that is made up of two different words. First is thermo, another is dynamic. Thermo represents the heat or something that is related to heat. And dynamic means not at rest, in the motion or in the progress or at progress. So, my dear students, here thermodynamics represents the heat in progress, the heat which is not at rest, the heat which is in motion. So, meaning by word, we can say that heat not at rest, especially in chemical reactions, the flow of heat during the chemical reaction is studied in thermodynamics. The flow of heat during the chemical reaction is studied in thermodynamics. In the 10th standard, my dear students, you might have studied, in the 10th standard, my dear students, you might have studied about exothermic and endothermic reaction. Will you please tell me what is an exothermic reaction? Any one of you? The meaning of exothermic reaction, please. Dear student, I am asking you something. Dear students,
इस रिएक्शन
Sir,
में हीट होते
sir,
yes, I am
इसको
listening.
बाहर
You
छोड़ना।
proceed, my dear student.
sir, reaction in which heat is released after reaction is called exothermic.
Wonderful. And what is endothermic reaction, my dear student?
इस रिएक्शन को करने के लिए हीट की जरूरत होती है
You are right. You tell me, no problem. Please.
Absorption of heat.
Don't feel shy.
जिस
Go
रिएक्शन
ahead. Please.
को करने के लिए हीट की जरूरत होती है
Very good. So you know that in a chemical reaction even, we have lots of reaction where heat is either produced or heat is either needed for a particular reaction. So those reactions in which heat is either produced or heat is either needed for doing a particular reaction, these kind of reactions are known as the endothermic or exothermic reactions. So we are well aware that in a very or in a lots of reactions, we need heat or heat is involved during the chemical reaction. During a particular chemical reaction, temperature may increase or temperature may decreases. Sometimes the reaction mixtures get cooled or sometimes the reaction mixtures gets hot and you have your bottom of the vessel either cooled or become hot. So this is what it happens all the way when, my dear students, we study about the various chemical reactions. When we study about the various chemical reactions, we know that heat is either required or heat is either produced. Let's move further. Let's move forward. Chemical energy stored by molecules can be released as heat during the chemical reaction when a fuel like methane, cooking gas, or coal burns in the air. We have seen in many examples that the energy is released during the process of combustion when the substances or fuels get burned. Same way, my dear students, the chemical energy may also be used to do some mechanical work. When a fuel burns in an engine or to provide electrical energy or in a galvanic cell like dry cell, you might have known about this, my dear students, that when there is a dry cell, the energy in the dry cell is obtained from the various chemicals. Same way, my dear students, the energy that is produced in the engine of a car or if it is produced in the engine of your scooter or bike, that is also obtained by or that is also obtained from the uh, various um, burning of the various chemicals which are known as the petrol or diesel in your engine. Thus the chemical energy is converted into the mechanical energy and we do some mechanical work in these cases. The various forms of energy are interrelated. See, we have various forms of energies. These are all various forms of energy are interrelated. That means you can convert the chemical energy into mechanical energy. How do you convert chemical energy into mechanical energy? You do it by doing some work inside or by using the burning process or use the galvanic cell, and this is how it goes on. So various energy forms, whether it is chemical energy, mechanical energy, or the other energy which are related, we can interconvert them. These forms of energy, they can be interconverted into the various forms. So this is how we understand. So the energy can be transformed from one form to another. Once again, the various forms of energy are interrelated and under certain conditions, this may be transformed from one form to another. Now we are going to study what is the subject matter in our this chapter. So let us study about the subject matter of the chapter. Let's pay attention. The study of this energy transformation forms the subject matters of the thermodynamics. So this study of the uh, energy transformation is the subject matter that we are going to study into the thermodynamics. Now let's think thermodynamics. What are those areas? What are those points in which thermodynamics deals with? The laws of thermodynamics deals with the energy changes of macroscopic system. You might have heard about microscope. What is microscope? Microscope is the device by which we can see very small things. Exactly opposite to microscope, we have the word macro. So micro and macro are the opposite words to each other. Macro means something that is bigger in size and we can see with the naked eye. So here the thermodynamics deals with the energy changes of the macroscopic system that you can see with the naked eye. This energy changes that takes place into the system which you can see with the naked eyes is the or thermodynamics deals with such systems. These systems involves a large number of molecules rather than microscopic system involving a few molecules. So here we will study the systems which are full of molecules, which have the large number of molecules with them. Thermodynamics is concerned about what is thermodynamics? What is thermodynamics concerned about? What it is worrying about, or what it is try to solve the problems of those areas. So let us study what are those areas or what thermodynamics is concerned about. Thermodynamics is not concerned about how and what rate the energy transformation are carried out. Please remember, to understand something what it is concerned about, let us first know what it is not concerned about. So thermodynamics is not concerned about that at what speed the chemical reaction takes place, or at what speed the energy is produced or required, and how during the reaction how the energy is produced or required. Thermodynamics is not concerned with this, but it is based on the initial and the final state of the system undergoing a change. So in thermodynamics, we study the initial and final state. We study what happens before the reaction and what happens after the reaction. We are not concerned much about how the reaction took place or what pathway the reaction goes and what pathway the changes are taking place. Thus, thermodynamics is worried about, or thermodynamics is concerned about the initial and final state of the system, initial and final state of the material or the chemical reaction. When laws of thermodynamics can be applied, when we can apply the laws, the various laws of thermodynamics in our daily life. Laws of thermodynamics apply only when a system is in equilibrium. Please remember that thermodynamics is applied when the system is in equilibrium. That means system goes in such a state where the reaction goes, but its concentration of reactants and products become constant. We have just seen that thermodynamics can be used, the laws of thermodynamics can be applied only for the initial state and final state. Initial state, the reactants are not being reacting, that is why their concentration is constant. At final state, the reactants have been transformed into products, and if some reactants are still present, they do not react further, their concentration become constant, and the amount of product whatever it was required to be produced, that has already been produced, and now no further product is going to be produced. In that condition we can apply the various laws of thermodynamics. Please try to understand this. These are very important point, my dear students, that you should know that the thermodynamics or laws of the thermodynamics can be applied only when a system is at equilibrium, or system moves from one equilibrium state to the another equilibrium state. That means if the system is in the equilibrium, or system is moving from equilibrium state 1 to the equilibrium state 2, in between whatever that is taking place, we do not apply the laws of thermodynamics to not equilibrium state, or in between the equilibrium state 1 and equilibrium state 2, whatever it happens to that particular state, we cannot apply the laws of the thermodynamics. Laws of the thermodynamics should be applied when there is equilibrium established in the system. Macroscopic properties like pressure, temperature, do not change with the time of a system in equilibrium state. So why do we call this pressure and temperature as a macroscopic property? Because, my dear students, that pressure and temperature, this pressure and temperature generally cannot be shown by single particles. A single particle does not show pressure, a single particle does not have temperature. It's a bulk property. To show pressure, to show temperature, a system requires huge number of molecules, huge number of particles, and that is why pressure and temperature can be considered uh, uh, as a macroscopic properties, and macroscopic properties like pressure and temperature do not change with time for a system in equilibrium. So please remember that when a system has acquired the equilibrium, the temperature and pressure does not change at equilibrium. Please remember that during the equilibrium or when the system has obtained the equilibrium state, the macroscopic properties like pressure and temperature does not change. Now let's find answer for some questions like what questions do we need to study? How do we determine the energy changes involved in a chemical reaction or in a chemical process? How do we determine the energy changes involved in a chemical reaction or in a chemical process? Will it occur or not? It means chemical reaction. Here it represents the chemical reaction. Please. So there are, and the third question is what drives a chemical reaction or a chemical process? And the fourth question is to what extent do chemical reaction proceed? These are the four questions of our interest, or these are the four questions whose answer we are going to find during our complete discussion, my dear students. That how do we determine the energy changes involved in the chemical reaction? Will the chemical reaction occur or not? What makes the chemical reaction to happen, what makes the chemical reaction to proceed, and to what extent does the chemical reaction proceed. That means whether the all the reactants will be converted into products, or some 50% reactant goes and convert into products and 50% reactants does not convert into products. That means to what extent, to what percentage, to what amount, to what quantity does the reactant reacts with each other and give what quantity of products. That is what we are going to find out, or these are the questions that we are going to find out by studying this particular chapter. Now, to understand this chapter, we need to be very much aware about few thermodynamic terms. So let us study those thermodynamics terms. Let us understand these thermodynamics terms. Please, my dear students, if you do not understand anything, you need to ask me, because it is very necessary to understand the concept of this chapter, that you understand these terms very well. The first term that we are going to study about is a system. A part of the universe that is under the scientific observation or under the scientific study is called system. Something that you start studying, you study it scientific way, that something what you are observing is considered as a system for you. Then, my dear students, we need to study about the another term called surrounding. The part of the universe other than the system is called surrounding. So anything which is not under your observation, anything which is not under the scientific study or scientific observation can be considered as a surrounding. So this is how, my dear students, we truly understand about the surrounding as well as the system. Generally, we study the immediate surrounding. Generally, we study the immediate surrounding of the system as surrounding, because the system can interact with the or affected by the neighboring surrounding only. So generally, we say that all the rest of the universe is surrounding, but we consider the nearby or neighboring surrounding as a surrounding, but this is the general case. Whatever that really affect directly the system, we should consider it as a surrounding and study, or we should do the scientific study. The region of space in the neighborhood of the system constitutes its surrounding. Once again, this is again a point by which you can understand the surrounding. The region of space in the neighborhood of the system constitutes its surrounding. Now, my dear students, we can simply say that the universe is equal to the system plus the surrounding. So the system and the surrounding makes the universe, because the system is under your observations and surrounding is something that is the rest of the part of the universe, and ultimately the addition of system and surrounding gives us the universe. Now a very important point we need to study here is about the boundary or a wall. So let us try to understand about the boundary or a wall. Something that separates system and surrounding, something that separates system and surrounding is called wall or boundary. Something that separates system or surrounding is called wall or a boundary. So this is how, my dear students, uh, we understand about boundary. Boundary is something that separates the system from the surrounding. If you do not understand, don't worry, I will explain it with even the example. If we study the reaction taking place between two substances, remember if we study the reaction between the taking place between the two substances, substance A and substance B, kept in a beaker. Now we have kept this in a beaker. So you have a beaker. This is your beaker. In this beaker, you have substance A plus B. This is your substance A and this is substance B. These both are going to react. So what makes your system? This reactant A and reactant B, which are reacting, they makes your system. So reactant A and reactant B is your system, or the reaction mixture inside the beaker is your system. Suppose A and B are dissolved in water. So if A and B are dissolved in water, this A plus B plus water become your system. So this is how, my dear students, the reaction mixture become your system. Now what we want to study is next is what is surrounding. The room where the beaker is kept can be your surrounding. So the room in which the beaker is kept is known as your surrounding. Then what is the wall or boundary? The wall of the beaker is your boundary. So here, my dear students, we can easily understand about the boundary or about the walls. So when we study about the walls or surrounding, you can easily say that this wall of the beaker is the boundary that separates the system with the surrounding. This room in which you have kept, this is what it is, your surrounding, my dear students. So something that separates the surrounding and system can be considered um, as a wall or boundary for that particular thermodynamic system. Now, a very important point, boundary is designed to allow observers to control and keep track of all movements of matter and energy in or out of the system. So why do we choose boundary? Why we determine boundary? We determine boundary, or the observers or scientists determine boundary. Why? Because we want to study the system in a various way, in a different way, and we want to choose our boundary in such a way that makes us to control whether the energy of matter of the system can be exchanged with the surrounding or maybe not exchanged with the surrounding, or one of them may exchange, one of them may not be exchanged. This is how we study all, that we determine the wall by our own wish, that we can control the system, or we can control the system under our observation. Boundary may be imaginary. Sometimes we do not have the physical boundaries, but we may have the imaginary boundaries. That means boundaries may be imaginary. That means they may not be physically present. We may think that this something is there which behave like a boundary, but physically sometimes the boundary or wall may not be present. Boundary of wall can be of various types. Now we can study the various types of boundary or various types of walls, my dear students. So let's have a look at that. First, we should study about the adiabatic wall. Let us see what is the meaning of the adiabatic wall, my dear students. A wall that does not allow exchange of heat between the system and the surroundings. Remember that the type of wall which does not allow the exchange of heat, it does not allow the exchange of heat and does not allow the exchange of heat only. So when the wall which does not allow the exchange of heat with the surrounding, such wall can be considered as a adiabatic wall. Then isothermal wall, a wall that keeps the temperature of the system constant. Remember, a wall that keeps the temperature of the system constant is called isothermal wall. Adiabatic, not allowing the heat content of the system to be changed. Isothermal does not allow the temperature of the system to be changed, or does not allow the temperature of the system to change. Isochoric wall. Isochoric wall, that is the wall that a wall keeps the volume of the system constant, that does not allow the volume to be changed. And isobaric wall is the wall that maintains the pressure of the system constant, which does not allow the pressure to be changed during the process or during the change. We can have walls which may be combination of these walls, like we may have a isothermal and isobaric wall. That means the temperature and pressure both cannot be changed. Isothermal and adiabatic wall, that is not allowing the heat content as well as the temperature of the system to be changed. Isochoric and adiabatic, that means the volume of the system and heat content of the systems are not allowed to be changed. Isothermal and adiabatic, that means the temperature as well as the heat content of the system are not changed, but it can be isothermal, adiabatic, and isochoric wall. That means all the three, temperature, heat, and the volume of the system are not allowed to change, and so on. You may be think, or you may think even the other options, and any kind of wall we can set up for our system that we are going to use for the thermodynamic change. Now, my dear students, we want to study about the types of the system. So we may study the various types of the system. First type of the system that we want to study is known as the open system, a system that can exchange the energy as well as the matter with the surrounding is called an open system. Open system is a system that can exchange both energy as well as matter with the surrounding. For example, you can see a hot tea in an open cup. If you have hot tea in an open cup, the tea become cool after some time. That means the temperature has been exchanged with the surrounding. At the same time, some of the water vapor come out from the tea. That means the matter of the tea can also be exchanged with the surrounding. That kind of system is known as the open system. Then we have the closed system. The closed system, the type of system that allow exchange of energy but does not allow the exchange of matter, is known as the closed system. So if you take tea into the closed vessel, you have tea here. So in the closed vessel, if you have tea and this part is completely closed, but this part or this vessel is made up of metal, which allows the heat to pass through. So the tea inside this become cool after some time because uh, the energy can be exchanged, but the matter cannot be exchanged. So none of the water vapor goes outside from this container, but only the temperature or only the heat energy can be exchanged. And this type of system is called the uh, closed system. Hot water filled in the closed vessel made up of conducting material like copper. This is the example for the closed system. And then the last type of system that we want to study today is called the isolated system. The type of system can neither allow the exchange of energy nor allow the exchange of mass or matter. This is what it is known as the isolated system. So this is how, my dear students, we understand about the isolated system. We have two examples for the isolated systems. Reactants in the thermos flask for few hours. If you take a thermos flask and you take reactants into the thermos flask, this is what it is going to be, the isolated system, because neither energy nor the uh, mass is exchanged with the surrounding. Thermos flask is a kind of flask that does not allow the temperature even to be changed, and reactants flow in a closed insulated vessel for few hours. Insulated vessel is again a vessel that make the temperature of the reaction mixture constant, as well as it does not allow the matter to be exchanged with the surrounding. At the same time, universe is also an isolated system because the total energy of the universe remains constant. Total energy and total mass of the universe remains constant, and that is why we call universe as an isolated system. So this is how, my dear students, we end here with the today's discussion. Let us revise whatever we have studied in today's class. Today we have started studying a new chapter called thermodynamics. In this chapter we have studied the meaning that heat in motion. So during the study of thermodynamics, we study how the heat is either required or released during the chemical reactions. Then what is the subject matter of the thermodynamics? That the subject matter of thermodynamics is the energy transformation in the systems.